Look up at the night sky. For millennia, humans have gazed at those pinpricks of light, weaving stories of their origins. Today, we have a different, more profound story to tell, one not of gods, but of geometry, quantum whispers, an expansion that shapes everything, and invisible forces that govern the cosmos itself. The most pervasive image of our cosmic origin is that of a colossal explosion in empty space, flinging galaxies outward like shrapnel. This picture is deeply misleading. A better analogy is to imagine a vast, infinite loaf of raisin, bread baking in an oven. Each raisin is a galaxy. As the dough rises uniformly, every raisin moves away from every other. There is no center. The very fabric of space itself is stretching, creating more room between all points. This is the essence of cosmic expansion. This revolutionary idea found its evidence in the early 20th century. Edwin Hubble discovered that light from distant galaxies was stretched to longer, redder wavelengths, a redshift. The farther away a galaxy was, the greater its redshift, and the faster it appeared to recede. This relationship, Hubble's law, showed the universe was stretching. But the story had an unexpected twist waiting. For decades, we assumed the collective gravity of all matter would slow this expansion. Then, at the close of the 20th century, observations of distant supernovae revealed a shocking truth. The expansion is not slowing down, it is accelerating. Something is pushing galaxies apart with ever-increasing strength. We call this mysterious something dark energy. It is not a substance we can touch or see. It seems to be a property of space itself, a repulsive force that makes up about 68% of the universe's total energy content. It is the dominant force shaping our cosmic fate. But dark energy is not the only invisible player. When we observe how galaxies spin and how clusters of galaxies move, we find they behave as if they contain far more mass than the visible stars and gas can account for. This missing mass, which binds the cosmos through gravity yet emits no light, is dark matter. It makes up about 27% of the universe, a cosmic scaffolding upon which the visible universe is built. This leaves a humbling reality. The ordinary matter that makes up every star, planet, and living being constitutes less than 5% of the cosmos. Over 95% of the universe is made of dark, unknown components. Run the cosmic film backward in your mind. Galaxies converge. The universe becomes denser, hotter, and more extreme. Extrapolating all the way back, we arrive at a state of unimaginable density and temperature, roughly 13.8 billion years ago, a phase we call the Hot Big Bang. This hot, dense state is as far back as our classical equations can confidently take us, but it may not be the ultimate origin. Pushing our equations back toward time zero leads to a singularity, a point of infinite density where our laws of physics break down. This signals that classical physics must yield to quantum mechanics. At the incredibly tiny Planck scale, space-time itself may become a seething, probabilistic foam. This insight has spawned breathtaking ideas about what could have preceded the Hot Big Bang. One leading concept is cosmic inflation. This proposes that a fraction of a second after the putative singularity, the universe underwent a brief exponential expansion driven by a repulsive energy inherent to space. This inflationary surge would have ironed out wrinkles and stretched microscopic quantum fluctuations to cosmic scales, planting the seeds for all future galaxies. It elegantly sets the stage for the traditional hot Big Bang expansion we observe thereafter. Looking even further back into the realm of quantum gravity, ideas become more speculative. Perhaps our universe emerged from a quantum fluctuation. Or maybe it is one cycle in an eternal series of expansions and contractions, a big bounce. Some theories suggest time itself loses its meaning at the earliest moments, with the universe having no distinct initial edge. This is where the true wonder lies. We have pieced together a robust evidence-backed history from a fraction of a second after the beginning to the present cosmic web. The hot Big Bang describes that evolution masterfully. But the ultimate questions of origin, what is dark energy, what is dark matter, and what, if anything, came before that hot, dense state, remain wide-open frontiers. We are privileged to live in an era where we can probe these mysteries. The cosmic microwave background is our most ancient artifact, a baby picture of the cosmos. Future observations of gravitational waves from the universe's first moments or deeper studies of the large-scale structure may one day provide clues about inflation, dark matter, or the nature of dark energy. The journey is not about finding a final, comforting answer. It is about the relentless, thrilling pursuit of understanding. Every answer unveils deeper questions, and in that cycle of doubt and wonder, we truly connect with the vast, ancient, and magnificent universe we call home. Yet even as we uncover these cosmic truths, one question quietly lingers beneath all others. Why does any of this exist at all? Physics can describe how the universe evolves with astonishing precision, but when we ask why the laws themselves are the way they are, the equations fall silent. Why does space expand? Why does dark energy have the value it does? Why didn't the universe tear itself apart or collapse back into nothing? One striking fact stands out. The universe appears exquisitely balanced. If dark energy was slightly stronger, galaxies would never have formed. If it were weaker, the universe might have collapsed long ago. The same is true for the strength of gravity, the masses of particles, the speed of cosmic expansion. Tiny changes, and stars, planets, and life would be impossible. This has led some scientists to a controversial idea. The universe may not be unique. According to certain theories, especially those emerging from inflation and quantum physics, our cosmos could be just one bubble in a vast multiverse, an ocean of universes, each with different physical laws. In most of them, complexity never arises. But in a rare few, like ours, conditions happen to allow structure, chemistry, and consciousness. We observe this universe not because it is special by design, but because only such a universe can produce observers. This idea, known as the Anthropic Principle, is deeply unsettling to some and deeply intriguing to others. It challenges the notion that the universe must have a single, elegant reason for its existence. Instead, it suggests that reality may be far stranger and far larger than anything we can directly observe. And yet, despite all this cosmic vastness, something extraordinary has happened here. From a universe dominated by dark energy and dark matter, from particles born in the first seconds after the hot Big Bang, from stars that lived and died long before Earth existed, conscious beings emerge who can ask questions about the whole. Atoms became molecules. Molecules became cells. Cells became minds, capable of tracing the history of the cosmos back nearly 14 billion years. The universe, in a very real sense, has become aware of itself. Every telescope we build, every equation we write, every signal we capture from the depths of space is part of that awakening. We are not separate from the cosmos, we are a continuation of it. The same physics that drives galaxies apart also pulses through your body at this very moment. So when you look up at the night sky, you are not looking at something distant and unrelated. You are looking at your own origin story. And the story is not finished. The universe is still expanding. Dark energy is still at work. New questions are forming even as old ones are answered. Somewhere in the cosmic darkness, discoveries are waiting about space, time, reality, and perhaps even what lies beyond the boundaries of our understanding. We do not yet know where this journey ultimately leads. But we know this: as long as there are minds curious enough to ask, the universe will never truly be silent. The universe is vast, dark, and still unfolding. We may never know how it truly began or how it will end. But for a brief moment in cosmic time, the universe learned how to wonder through us.